Hello students, welcome to Pathak's Computer Academy online classes. In the previous video, we learned about introductory part of NumPy, that is numerical Python package. And we learned that other than the list, how can we create an array using this package? And now, today we will learn that whatever we have created the array, on that array, indexing, slicing, and other than more functionality can be applied. Okay. So the content today we covered indexing in NumPy array, then slicing, how iterative operation can be performed in NumPy array, and at last we will see how to concatenate and split in NumPy array. So let's start. As we know that whatever we know about array in C or Java, and whatever the operation can be performed are same as in NumPy array. Thus, array indexing is same as array element. How to access? Okay. Array of 1th position, array of 1th row, 2th column, if we are talking about two-dimensional array. Clear? Now, what is slicing? I already discussed. Slicing have 3 points. First one is start value, colon, stop value, colon, step. And in these 3 values, stop is the important one. We cannot ignore. So with the help of slicing, we can access sub array. Next one is iterating. Iterating means going through elements one by one from first element to the last element. Joining or concatenating means if you have 2 or more NumPy array and you want to add in a single array, then this operation, this functionality can be used. And at the last, just opposite of concatenating is splitting. If you want to divide one NumPy array into 2 or more array. Clear? So let's start with one by one. So indexing in NumPy array. As we know that indexing start with 0. Firstly, start with one-dimensional array. Here, in the first line, I have created ARR, and in this, with the help of np.array, in bracket, I supplied one list, and in list, there are 4 elements. So, ARR will be treated as NumPy array. Okay. To do this, what is to be done? This NP is the alias name of what? NumPy. And to do this, we have to write what? We have to import NumPy and now I want to give an alias name. So as NP. So now NP is treated as NumPy. So with the help of NP, we can use a function that is array through which we can create one-dimensional array. So in the second line, I want to access first element. So what to do? Array of 0th position. As we know that array is a contiguous memory location starting with 0 to n minus 1 position. So 10 is printed. Now I want to check array of 3. So it start with 0, 1, 2, 3. The last element 40 will be printed. And if I want to try to access beyond the limit, then it will show an exception, and that exception is index array. And it shows that index 5 is out of bound. Clear? The same thing can be happen with negative indexing also. As we know that Python supports negative indexing. So it starts with -1 up to -n position from right to left. Clear? So -1 will be treated as 40. So 40 is printed. -4 will print the first element, that is 10. And again, if I try to access beyond the boundary of the indexing limit, then it will show an error. Clear? Now the same thing can be happened with the two-dimensional array. Here I have taken two lists and pass as two-dimensional array. So if I want to access the 0th row and 1th column, so it will print 20. Why? Because 0th row is this one is 0th row, and this one is 1th row, and in 0th row, this is 0th column, 1th column, 2th column. So I have to pass like this, not like this in Java or C, like this, ARR. Then in one bracket, I have to supply row, and in another bracket, I have to supply column value. That is not done in the case of Python NumPy array. I have to use in a single bracket with the help of comma, I have to supply what? Row and column value. Clear? So I think indexing is very clear to you. Moving on further, slicing. As I already told you, there are three things: start, stop, and step. I have included all these three things. First of all, I'm going to print ARR, so it will print like this. Now, I'm going to start with 0th position and go up to 2, and it will go 2 minus 1, that is 1th position. So 2 value will be printed, that is 10 and 20. So here I have given start and stop value. Now I want to give only start value. So it can be possible. ARR 0 colon no value will be supplied. So interpreter will treat it as we have to move up to the last element of the array. So all the elements will be printed. Now in the third case, I have given the stop value. Starting value is not given. So by default, it started with the 0th indexing, and it will go 3 minus 1, that is 2th position. So 0, 1, 2, 10, 20, 30 will be printed. And in the last example, I have given all the three values, that is start, stop, and step. What they are? 0 to move on 4 minus 1, that is 3. So I have taken all the elements but step size is 2. So I want to skip one element and then print second element. Then third element will be skipped, fourth element will be printed. So here first element is printed. Now second element is skipped. Now 30 is printed. The same philosophy can be possible in slicing, that negative slicing can be possible. But in slicing, I already told you that sub-array can be selected from left to right only. Okay. And if the value is not given like this, then empty array will be returned. Like this here. In this example, what I have done? I have given the starting position is -1. That means it will start with 40. And stop value is -4. That is -4. That is what? -1, -2, -3, -4. So it will never go from right to left. You have to think about that. Okay. In indexing, that can be possible because you are going to fetch only one element. But when you are using slicing, then it should be left to right only. So like this here, -4 to up to -2. That is -2, -1. That is what will happen? -4. That is from start with 20 and then -3, -2, -1. That is -3 position. The slicing can be done. -1, -2, -3. That's why 10 and 20 will be printed only. Clear? Here, starting value is not given, but stop value is given -1. So -1, -1, that is -2, up to -2, that is 30. It will go up to 30 from starting value 10, 20, 30. Again, I have given started with -1, but no stop value. So -1 is still 40 and there is no such element other than this. So 40 is printed. Okay. Now here I have given all the three values -4, colon, -1, colon, 2. So 10, 30 will be printed. So I think slicing is very easy to you. Now, iteration. Iterating means going through elements one by one. So here you can see that for I in ARR, print I. So 10, 20, 30 will be printed. Now, in the second example, I have taken two-dimensional array. So in this, if I'm going to print, so it will not print 10, then 20, then 30, then 40. It will print 0th row as a whole and 1th row as a whole, like this. Clear? So if you want to print 10, then 20, then 30, one by one. So what to do? You have to use nditer function. Okay? Or you have to use nested for loop. as we already done in C or Java. For I in A2, for j in I, there is, you will see that there is a indentation error. So you have to be very careful that for should be under this. So if I am going to print j, then 10, 20, 30 is printed. Now j is over, it will go again. I will increment it to 1. Now in 1th row, all the j values, 0th position, first position and second position will be printed. If you don't want to do this, then there is a function available in NumPy array, that is nditer. ND means n-dimensional, ITR means iteration. So it will print simply 10, 20, 30, 40, 50, 60, one by one. So what to do? For I in np dot nditr function, and in nditr function you have to supply array A2 and then print I. Clear? So there are two things. First one is you already know. Another one is with the help of function nditr. I hope you understand how iteration can be worked with one-dimensional or two-dimensional array. Now concatenating arrays, as the name suggests, it will add two or more arrays in a single. For this, concatenate function can be used. So import NumPy as np, first array is created, second array is created. Now, in the third array, I want to concatenate these two arrays. So I have to supply in concatenate function A1 comma A2. So here you can see that ARR will have all the elements available in A1 as well as in A2. Other than this, there is a one more function known as stack, and the functionality is the same, but it will take care or store elements like first element is treated as first array, second element is treated as second array. So like this. So it shows that if you use concatenate, then these two arrays are combined in a single array. But if you use stack, then it will treat it as two-dimensional array. This is the basic difference between concatenate and stacking. Now in the last, splitting arrays, it is just reverse operation of joining. There is a function array underscore split. Okay, and there are two arguments you have to supply. First one is whatever the array is, and the next one is how many splitting you want to do. So here you can see that A is supplied, that you have to take these values, and these values are broken into three sub arrays. So here you can see that 10, 20, 30, 40, 50, 60, three arrays are created. Okay. And if you supply something which is not common fraction, of the splitting, then it will automatically adjust from the end accordingly. So here you can see that two arrays have two values and last two arrays have only one value. Why? Because we want four arrays and there are not sufficient elements available to distribute equal amount of elements in each array. Okay. Other than this array underscore split, there is another function is available known as split, but you have to very careful about that. If in split there is no common elements to distribute, equal amount of elements to distribute, then it will give value error exception like this. In M, np.split a comma 2. Now I want to split these 6 elements into 2. So 6 by 2, that is 3. 3 elements are splitted in each array. But if I want to split in 4 sections, so there are no such facility is available through which we can distribute 6 elements into 4 array. So it will show an exception. So this is the basic difference between array underscore split and simply split. Array underscore split will adjust accordingly and automatically, but split will give an error. Okay, so that's all for today. Today we learned in NumPy array how indexing and slicing can be possible and how joining and splitting functionality can be achieved. I hope you enjoyed the session. In the next session, we will see some arithmetic operation that can be performed in NumPy array. Till then, bye-bye and do practicing. Without practicing, there will be chance that you get an error. Thank you so much.